ainus küsimus on see, et keegi mulle rääkis, et ma pean inglise keeles rääkima.
Yes, sure.
So,
sorry. It was my mistake.
Okay, I will speak in English because I was thinking that if Alek was speaking in Estonian, but I think that those who don't understand Estonian, they will not get free beer, so we will get more. Okay, I have just returned from my trip to South America, so I'm still in a jet lag condition. So if I bore you to death, then please excuse me, but I'll try to do my best. So I'm Anton Keks from Codeborn. Who knows what Codeborn is? Okay, so I'm not going to talk about it much. Basically, we are the good guys making well-crafted software. But now today I'm going to talk about our way, actually my team's way of doing mobile apps. And I will be reasoning why it is, to my mind, the best way currently to do it. And there is a lot of actually discussions on the internet, especially the second half of last year. There was a lot of flame wars about how to do your mobile apps best. But I will just express my opinion and we can discuss it later. There are of course pros and cons. So I will tell you later what this hybrid means, if you don't know it yet. But let's look at usually people actually when they think about building mobile apps. I don't know actually if I need to wear this. Do you hear me? Okay. It's for the video. I guess the technical stuff today is pretty difficult.
It's spring. It's that why.
Nothing works, and everything is forgotten. So usually people, when they think about starting a mobile app, they think about doing native or non-native. What does basically it mean? Native is in mobile apps. It means usually the reasons people use is like at the past Olympic Games. The motto of the Olympic Games is Citius Altius Fortius, which means that is higher, faster, stronger, whatever. And that's basically what people say when they think that they should build only native mobile apps. And only native means that you actually write all your code, which is very specific to the concrete operating system you are writing for, like the iPhone or Android. So that's basically the same situation as we had in the 90s in the desktop world. This is when all people did is actually they wrote native Windows applications for the desktop, and of course you remember the shareware model and whatever. That's all in the past. That's the point. And it was the era of 90s and the first half of 2000s was followed by actually the great migration of apps to the web. Why did it happen? Because it's much easier to actually distribute your apps. So actually have your apps hosted somewhere and your user just use it. It's much easier that you don't need to update it and whatever. Now actually mobile phones or mobile apps, I think they are repeating the same scenario. So except for iPhone 1.0, if you remember when I was a lucky owner of iPhone 1.0 that was never actually sold in Estonia. It didn't have any official possibility of running third-party apps on it. But Steve Jobs did tell us, so the way to actually do the apps for the iPhone 1, it was to create web applications. And that's why there is a lot of tricks in HTML and CSS that you can do for your web applications to look actually and behave more like native ones. So it still can be used. You still can even include the web applications on your desktop in an iPhone. and they will have an icon, they will have a splash screen, they will launch, and it will all look like the native applications almost, despite the fact that the content is actually loaded over the network. So that was the vision of Steve Jobs until iPhone was jailbroken, and then he understood that people actually want to have stuff installed on their mobile phones. And it actually makes sense because sometimes I'm not online. And iPhone 1.0 was released in 2007. Especially at that time, the internet traffic was more expensive. Now it's becoming more and more cheap. And even the data roaming is becoming more and more cheap. So, that's how actually native apps were born. And Apple discovered that it's a very good revenue stream for them and for the developers to just install some stuff on your phone. And in the beginning, they forbade actually non-native applications. But later, they have made it easier for people to do non-native. So with mobile, it's worse. If we look at the non-native, if we look at the native approach of writing applications, because after iPhone shortly came the Android, and Android is a completely different operating system, completely different way of writing your applications, and there's more. It's actually the situation is much worse than it was in 90s with the Windows apps, because in 90s it was 90% of Windows users, and even more than 90%. Now, actually, there is quite a big market share. At least, if you want to be any serious in a mobile apps market, you need to have two versions of your mobile app. And it's expensive to maintain several of them. And if we think about the future, there are lots of guys who are actually currently trying hard to gain a bigger market share. Microsoft, it was said that Microsoft now is close to 10% in Europe. It is quite low in the rest of the world, but in Europe it's gaining market share. It means that you need to consider, in Europe you need to very soon consider the third one. And there are also a lot of guys who actually have users and will have more users in future. So can you imagine writing so many mobile applications from scratch over and over again? I'm a very lazy developer. I don't like doing the same stuff several times over and over again. So, and basically the basic formula for calculating how much your mobile app costs is just multiply the number of platforms by the cost of development. It's roughly as simple as that. So that's why that's not the native approach, is not how actually I want to do that. So my background and the stuff that I'm going to demonstrate to you soon is that we at Codeborn, we are doing internet banking for Russia primarily right now. So we have several banks already, and 2 of them are already live, and they have won different kind of best internet bank awards in Russia. So the point was that as we're doing the internet banking stuff mainly, at first we weren't thinking about mobile version. But currently nowadays actually it's quite hard, almost impossible to imagine some kind of serious internet banking without a special interface for the mobile. So, but we actually needed to do it quickly, and that's why we chose the non-native approach. But so something has actually helped us again, just like with the web world in desktop applications. So it's the same. Why not have the same with the mobile apps? There are, of course, a lot of other tries how to actually do cross-platform mobile development. There is, for example, Xenian, or how to pronounce it correctly. These are the guys who think that you can write your code in C# and then compile it to the different operating systems, but they have no option of actually reusing the GUI. They still say that you can reuse at least something like 30% of the code, but you need to write the other 70% actually multiple times. And there are some other guys who actually compile JavaScript to native code and try to actually let you write once and run anywhere, but it's still quite complicated. And what I like when I choose a framework or something that I do work development with, what I like is that it will not actually hold me in place. It will not limit my possibilities. So if I use some kind of hardcore framework like Simian or some accelerator or something like that, that actually have their own language, their own framework, and they will build it for different platforms. It actually, if I need at some point to actually bypass it, to do something differently, not the way how they imagined, then I get into trouble. And I will soon show you the mobile app, the mobile internet banking of Bank St. Petersburg that we worked on. With them, actually, it was, forgot what I wanted to say. That happens when you're on a jet lag. But anyway, it probably comes to my mind later. So when you do cross-platform with web, you are already native on some of the platforms. There is actually Windows 8 has the HTML5 as a native citizen. Then there is the Palm Web OS, which is not very popular right now, but still. And there is the emerging Firefox operating system for mobiles, which will have some real mobile phones released, I think, in the second quarter of this year. Then there is the Ubuntu Touch. They will have their first devices in autumn. So basically this year we'll see a lot of new platforms. And most of them actually, they think they actually focus on web mobile apps already. And by web, I mean not the ones that are downloaded from the internet, but the ones that actually just HTML, JavaScript, and CSS, but they can be stored on the device. So that's the big difference. And if we remember about the iPhone 1.0, as I already mentioned, it also had the web technology as almost native, or the only way to do official apps. So, and this stuff is developing very fast. It's actually, there are lots of new technologies for HTML that actually will make writing apps in HTML and JavaScript basically easier. So there is the WebGL. So those who say that web apps on mobile don't perform, then look at WebGL. It actually, I have a demo actually here. Let's see. So that's the periodic table. It's complete HTML and JavaScript. You can see it can do different kind of tricks. You can open this URL on your mobile phone. It works just as good on mine as it is here in the browser. So basically, there is no such a thing that the web technology is somehow slower in the GUI than the native approach. So there is just the question of how do you make it and what technologies to use. So there are lots of CSS-free stuff, a lot of new JavaScript APIs. For example, if you don't know, then actually already now in many browsers you can use an SQL database directly from JavaScript in your browser. And there's lots of stuff that you can do, and you don't need native code to do that. So, but there are some problems as well and disadvantages. So usually people say that it's slow and sluggish. It can mean actually two things. It can mean that it's either the network latency, meaning that if your app is downloaded from the internet the first time you launch it or the next time you use it, That's actually the problem that can be overcome right now by packaging a part or a whole of your app actually inside of the phone. So basically, then the user downloads your app. It doesn't need actually to go and call home. It can work completely offline on the phone. So that's not the stuff. When I'm talking about web apps and mobiles, I don't mean that they are online. They can be offline as well. So if your app is slow, then probably you need to include at least parts of your app and directly on the phone, so that they are not downloaded, they are instantly accessible. Then there is the second problem is the UI. So nowadays people actually are very used already to good UIs and sleek stuff that moves very nicely without jitter. And people complain that usually these HTML apps, they don't do that. And I showed you this periodic table, and there are even more options how to do it properly. The problem with the sluggishness actually is mostly that the most popular framework that helps you to build your app and the mobile app, web mobile app, is actually a single page application, which is it can also be a single page web application which is stored offline. This is what it actually is. And there are some frameworks that help you build that, this single page web application. It doesn't mean that you have to use any of the frameworks. You can do everything by yourself. And I think that actually doing everything by yourself, almost everything, is a better approach than use jQuery Mobile, for example. jQuery Mobile, I think, is a little bit guilty in that disadvantage here that people often claim, that it can be slow. jQuery Mobile is written to support so many different browsers, including very old Android phones and whatever, so they had to compromise a lot on the UI. And that's why it doesn't look too good on all of the platforms. We still use it in our current projects, but I think if I would start a new one from scratch, I would do it without jQuery Mobile, do it with my own very simple framework. So JavaScript and plain jQuery are pretty good nowadays. So there's a second thing that I read very long articles about, that JavaScript will be never as fast as C. And I think it's, you cannot argue with that. It's the truth. But the thing is that the guys who actually claim that against writing the mobile apps in JavaScript, they are thinking about video processing or something like that. Why the hell would you do video processing in JavaScript? That's I think is pretty obvious. So basically JavaScript is good enough for like changing screens, for doing some animations, for doing whatever. Of course, it's not good for cryptography, video processing, or image processing, or something like that. So if you need to do these things, then most probably you will use some kind of library that is written in C, or you would use the native APIs of your platforms for this functionality. But the rest of your code you can write in JavaScript, and no one will actually notice that it's any slower than C or whatever else. So inconsistent look is also claimed, but that's also a matter of like doing it properly. So with CSS, especially nowadays, if you have seen the Metro UI of Windows Phone, or if you have seen the iOS 7, then both of them, they look actually, they are very easily replicated in CSS. Actually, those guys, especially the iOS 7, they made our life much more easier when we go and do mobile apps in HTML. So now it's all flat. It's there's only basic stuff in terms of the look. And you can do the look that mimics the platform. It's pretty easy to do, and many guys do that. So I think it's not a big problem. There are a lot of apps, native apps, that actually don't have a very consistent or nice looks, which are plain ugly, especially on the Android platform for some reason. The only disadvantage that actually really is a problem is the poor support of some probably CSS tricks on older devices. And by older devices, I mean mostly Android phones 2 point something. So there are still, Google actually publishes statistics every week, I think, about how many Android phones still use 2.3 and how many are already Jelly Bean or KitKat or whatever. So the problem is that there are still a lot of Chinese, very cheap, cheap devices that still run some very ancient Androids. And these guys actually who run them, they are the biggest problems for us. So from our user base, there are always some people with some very strange device bought on some obscure market in downtown Beijing that they actually, where our app doesn't work well or actually looks strange or looks incorrect. And we had to debug some of these problems, and we could fix some of them blindly because we didn't have these devices at hand. But these guys, there are a few of them, but they actually reduce the rating of your app on Google Play. They put you 1 star consistently every day. It's still not fixed, 1 star. And it's hard to fight them. Actually, one advice that I gave to our customers, just guys, buy them new phones. So there are not so many of these guys, and it's, I think, much cheaper to do it that way. And I think this problem is actually going away slowly, because Google now has understood that it's important to have people to upgrade. And now with the newer OSs, they try to do it easier for the manufacturers to actually upgrade the operating system. So I hope it will be better. Maybe if I would start a new app in autumn this year, maybe I would abandon Android 2 at all. So I would try it only for 4 and up. And this problem is actually, you have it also in the native world as well. So if you write native code and you need to support Android 2 or something, you need to write lots of ifs. So if the version of the Android system is like that, then I still need to use this API or another API. And sometimes you even need to use reflection in Java to support this old mobile. So you have this problem anyway, whether you use HTML or the native code. So now about the advantages. I already mentioned many of them. So it's almost the same as the slogan of Java. It's write once, run anywhere. That's what I like. So there are a lot of developers, a lot of competence, easy to find new guys actually, to switch new guys on the project and have them help you. So because if you do native stuff, then usually I've seen that there are separate teams who do Android, who do iPhone, for example. And then somebody is on vacation or some other problems why they're missing. So they have a hard time actually fixing bugs in the other platform. And in one company that I visited last year, they actually had, hey, we have this fantastic app for our web service. And, but unfortunately, we cannot update our iPhone app anymore because our iPhone developer has fired and nobody has any idea how the hell it works. So when you do cross-platform, you don't have this problem. And it's quite easy to test and debug. By testing, I mean the automated tests. So we have frameworks and stuff already set up and ready to test all of our code automatically after every commit on the build server. And if you write native code, it's much harder actually to do that with the native code, with the emulator. There are some tools, but still it's quite hard to use them. It's much easier to test HTML actually in a browser. There are lots more tools for doing that. You can also develop actually in your browser. So the thing is that when you are writing these HTML apps, you have basically your phone, you have the screen, and this full screen is actually a web view. And on most operating systems, at least on iPhone and Android, it's implemented with WebKit, this web view. It means that actually it's exactly the same engine that your Google Chrome has. And if you test your app in Google Chrome, if you develop it in Google Chrome, you actually don't need an emulator or your physical phone to develop it constantly. You just need it occasionally to run it. So basically, when I develop in my browser on my computer. It's easy to test, easy to debug, and then something is ready, we test it on the real device. So much more flexibility in many aspects. And one of the cool things that you can actually do, you can update your app over the network automatically. So there is a problem. If somebody has done iPhone development, then you probably know the waiting times and the Apple approval process. So the problem is when you release a new version of your app, it takes at least 1 week to review it. Sometimes it's 2 weeks and sometimes even longer. And you just need to wait. You can't be very agile with this approach. So you need to do new features, but they can be released only like once per month or something like that, because of Apple. So what you can do if you do the HTML stuff, you can actually call home at some point and see if there's an updated some resources for your app. You can download them and replace inside of the app. So it's not officially permitted, I think, at least by Apple, but they probably will never know if you don't do it very obviously.
Question. How do you then let your users know you have updated your application?
Your users don't have to know. If you open gmail.com, do you care if it's same as it was yesterday? You don't.
But then a user might think that I guess this application haven't been updated for a while. Is it still alive or something?
But if it works, then why the hell would I care? Actually, nowadays, even the newer Androids and newer iPhones, they now update automatically in background. So it's not too visible for the user, and you just skip the long approval process. But it's a possibility. It doesn't mean that you need to have that. And another possibility, an easier one, is not to download and replace some of your files, but actually just to serve some of your content from the real web and some of the content from the inside of the app. And that way you have the flexibility. And sometimes you can even, by serving some of the content from the real web, you can inject some code and show something differently if you need it. We did that with our old app when we were actually replacing the app with the major release with completely different design. We actually made some script on the server that will display to all users of the old app that it's now closed. Go and upgrade. So, and you can do that if you do it in HTML. So that brings us to hybrid apps. So the good thing is that JavaScript nowadays has all the cool APIs. You can do basically everything, but you can even actually access the accelerometer and geolocation data from the plain JavaScript in modern browsers without any tricks or whatever. But the problem is that not all phones support these new JavaScript APIs. And the other problem is that not operating systems have implemented all of them and that kind of stuff. So that's where Cordova comes to rescue. So what Cordova is basically a very simple stuff. It basically a tool that packages your HTML and JavaScript inside of the native app package. So it creates an APK for you for Android, it creates an IPA for iPhone, and whatever the extensions are for other platforms. So you just have a single source, and you tell Cordova, now build it for Android, or now build it for iPhone, and it will create a native app. So it's called actually a native app, but it contains non-native code basically. And what Cordova provides, it provides this container for you. So it provides this container inside of which your app is shown, and it also provides an API for you that you can use, basically a JavaScript API. And using this JavaScript Cordova API, you can actually use native services of the operating system. For example, there are some things which have no APIs in JavaScript, like accessing your phone book, or I don't know, accessing the camera of the phone or something like that. Mostly it's related to hardware. And Cordova actually provides you with this API. So you can actually, if you want to access the camera, you just call some JavaScript function, and your code, which calls this function, will run on both Android and iPhone, and it will actually open the real camera for you. So they actually take this cross-platform development burden from you and implement it themselves. So the good thing is that if there is a spec for some API in the W3C, then they actually implement the same API, only if it's not implemented already by your phone. So if your phone already has the navigator.geolocation stuff, then it will not interfere with that. If it doesn't, then it will actually substitute the standard API with its own implementation, and it will work on your phone. So that's the cool thing about Cordova. And the even more cool thing is the version 3. So before version 3 of Cordova, I didn't quite like it because you needed to have a separate project for Android, separate project for iPhone, and then copy your files back and forth and do that. And it was also called PhoneGap. Now with version 3 that was released last summer, it became much easier, and I will show you in a moment how it works. So let's see. So it's basically you have your HTML, CSS, JavaScript code packaged as native app and JavaScript API. And the another strength of Cordova is that it has a lot of plugins. And for example, when we needed to implement a QR code reader in our app, we actually could just install a plugin, and it worked for iPhone and Android, and we didn't need to write any of the native code. But why hybrid? Is because this JavaScript API is implemented in native code that we use. And the most important thing is that with Cordova you can actually write any amount of native code by yourself if you need it. So it doesn't isolate or actually limit your possibilities at all. So when iOS 7 was released actually for Bank St. Petersburg, we actually needed to release our app with the iOS 7 at the same time. The problem was that Cordova by default didn't support iOS 7 yet. So it's actually, and if you know anything about iPhone development, then with iOS 7 they have changed many things. And your app, if your old code just don't look nice on iOS 7 if it just run without modifications. So we needed actually to go and change some of the code and or Cordova's code, and it was very easy to do, and that's a good thing. Of course, Cordova iOS 7 support followed some weeks after, but we needed to release earlier, and we could do that, and it's an important thing. So, and we have our own plugins. So we actually have some of the native code, some of the things. I'll now demonstrate actually the app. I'll try to do it with the camera, because we don't have here the nice stuff, inputs and outputs. I hope you will see that. So let me try. So that's how the app looks like. It's basically, that's the opening screen, and it's a mobile bank basically. So here in Russia, usually for logging into internet bank in Estonia, we use like mobile ID or something like that, or PIN calculators. So in Russia, it's not such popular, and they don't have statewide accepted cryptography. So what they usually do is they use SMS passwords. So when you log in, you put your username, password, then SMS is sent to your phone. Then you look at the code, and then you enter it, and then you logged in. So it's quite a burden if you use your mobile device, and it's also not very secure if you want to access your mobile accounts on your mobile device, because the SMS is sent to the same device and it can be easily intercepted and whatever the stuff is. What we actually do is that when you install the app, the first time you actually authorize it once, and then you log in with the 5-digit code. So if I have a very simple code, and I actually log in only by entering like 5 numbers. Let's see. Actually, it's maybe. Okay. Now I have logged in. So the trick is to make it easier for the people. So in Russia, actually, mobile banking is more popular than internet banking almost. So it's quite important to do it right, to do it easy and nice. So what you see here is that we have the shake balance. As you see, I shake the phone. Now I see my balance. I shake it again. It says shake again. So this shaking stuff is actually, of course, we have no APIs in JavaScript for detecting the shake. But what we do is actually we use the Cordova's accelerometer API, and we detect the shake from JavaScript. And then we change the screen, and we also vibrate. You cannot see that, but when I shake, the phone vibrates, and it's also done from JavaScript, basically. So, and this app, I don't know, it depends on you if you say, does it look native or not, or how does it look, but we tried so that it would look, we don't care if it looks native or not, but we care that it would be beautiful and the users would actually like it. Now, what we have here is that we have the sliding menus, and these sliding menus, they actually are implemented as native controls. These sliding menus are not HTML, and for several reasons is to have this also fluidity, and there nowadays are some problems with implementing several different layers at the same time and with scrolling with HTML. So we thought that it would be easier to do these menus as native. But we populate this native menu from JavaScript. Basically, this menu is initialized from JavaScript, but we wrote like, I don't know, some 10, 20 rows of native code for each of the platforms. But still, most of our code is cross-platform. What we have here...
What does a native code do? Does it create a new web view?
No, it's not a web view. This is the list view on iPhone and on Android, and this is the web view that I'm sliding back and forth. So
this list is not populated by HTML?
It is.
HTML.
Actually, yeah, we have a function that we can call from JavaScript that actually will add icons and menu items here. And but the menu itself is
not HTML.
Is not HTML, but we actually use it from HTML, and that also gave us the opportunity to make it smoother when we needed it. So the cool thing about Cordova is that we can use native when we need it, and we don't have to use it all the time. So another cool thing is that the QR payment that doesn't exist in Estonia. So you can see the QR payment is that I show my QR to another person and they can scan it with their own phone. So I can press this button and the camera is opened, so I can, I don't know, camera through the camera is quite interesting thing, like a third reality. But the thing is that this camera also is a native control, but when it's closed, again, I get back to my web view. So that is the hybrid app. That's what I actually meant by saying that it makes sense to write hybrid apps nowadays. And this QR code is generated by the server. We also didn't need to write it in JavaScript. We just request the QR code from the server. And what else cools do we have? We have also the bump payment here. And bump payment, if you know about the startup company Bump that was acquired by Google, so we basically did the same thing. So if you have two phones, you can just bump them together, and they actually, because iPhone doesn't have any of the NFC or any of that, we actually do a very simple trick. We send the coordinates, geographical coordinates to the server, and the server actually matches them using also the time frame. There is some. It needed a lot of tuning, this algorithm, but in the end it works. So basically, when we bump, what happens? First, the bump must be detected in JavaScript code. JavaScript uses the accelerometer to detect the bump. Then I don't have anyone to bump with right now, but when the bump is detected, then instantly the coordinates are sent to the server, and then we wait for actually something like 2 seconds, maybe 2.5, for other bumps to match our bump. And if it arrives during this time and they match during the geographical as well, it's something like a radius of 1 square kilometer because of the inaccuracy of the coordinates when we are indoors. So
what's the saturation quotient? How many simultaneous bumps can you?
Well, actually, I looked actually yesterday at the logs. It's not used too much. It's just like a cool stuff to show. But actually, when I examined one of the bumps that I made a couple of days or a couple of weeks ago in St. Petersburg with some real people, then actually when I was looking through the logs and looking at my bumps, I saw that there are more people bumping at the same time, and it actually worked. So, but usually there are not many bumps at the same time. So there are like maybe several hundreds of bumps per day, but no, not too much yet, because it's not really marketed much, this feature. But in my mind, it's actually quite cool. We could use that in Estonia. That would be very nice. So if
you use the ready solution for that,
the
bump is already implemented by a company.
Because this company went out of business. It's one of the things, and the other thing why pay them is actually not a really difficult thing to do. It took me like 2 days to actually do that. So, yes, question?
As I understood, you sent GPS coordinates, and then you detect like 2 phones bumped almost with the same coordinates. What will happen if like 4 people bump at the same time and they stay close to each other?
If our algorithm works like that, if it detects more than 2 people who match as a group, then it actually says that there is no match, just in case. So, because it would be weird if you bump with 1 person and another table there are more people bumping and you get like.
In some cases, GPS accuracy can be like.
Yeah, sometimes we actually log we also send not only the coordinates, we also log the accuracy, and we actually take the accuracy into account. So with all of the coordinates, we also always get the accuracy. It can be up to 4 kilometers of the radius that the phone reports, and we actually use it to fine-tune the matching.
Question about how these hybrid apps work on different platforms. As we know, Google, Android, and iOS provide some guidelines on how the mobile applications should look like. And does Cordova offer any solution in the box how to follow this guidelines?
That's what I like. That's why I like Cordova. It has absolutely no limits or nothing to force you to do. So it has nothing to do with GUI actually. GUI is something that you implement by yourself, probably using some other framework or without any framework at all. So Cordova doesn't care how your app looks like. It just cares that you need to have index.html in your project that it can show in this web view. So basically, the other part of your question about what to do with the
how to make
how to look it consistent, how to make it look consistent. Cordova has some helpers for that in terms that you can redefine some parts of your code for different platforms. But you can also do that whatever you like. You can, the easiest way to substitute different CSS files for different platforms that would tune the look of the app But for example, our customers, they don't want the app to look different. They want the app to look the same on all the platforms because it's branded, it was designed specifically for them, and they use this brand in their advertisements and whatever, so they don't want it to look different. But it has slight differences. For example, when we show some alerts or something like that, we actually have we actually have replaced the JavaScript alert function with the native window with OK button and this kind of thing. So these windows, they look native. On Android and iPhone, they look differently, but the overall app looks almost the same. That is in our case, but it doesn't have to be like that. So it's quite easy for you to make different look for different platforms, if you like. So let's go further. So, and the cool thing also is the PhoneGap build. PhoneGap build actually, what's the point of PhoneGap and Cordova? Cordova is an open source incarnation of PhoneGap. So if you have heard about PhoneGap before, then Cordova is basically the same. So now PhoneGap is actually a distribution of Cordova. So Cordova is an open source project, and the guys at Adobe, because Adobe has bought the company that was named PhoneGap, they actually package Cordova sometimes and rebrand it as PhoneGap, but it's basically exactly the same thing. And PhoneGap releases come a little bit later than the releases of Cordova, so it makes sense now to use Cordova. But what guys at Adobe actually offer is the PhoneGap build servers. This is the build server, basically. And you can have your Cordova project, you can upload it to their server, and it will build it for all the app platforms for you. So basically, you don't need to have Mac to develop for iPhone, you don't need to have Windows for Windows Phone and whatever. You can develop everything on one single PC, then upload it to PhoneGap build and get all the packages back. So that at least it is advertised like that. When I spoke about this thing to some people who actually use PhoneGap build, they said that it's sometimes down and it's not too reliable, but at least in theory it looks cool. We use our own build servers. It's easier to have them in control. And the cool thing about Cordova 3, why I like Cordova 3 and not 2, is that it has also a nice command line interface, which is completely cross-platform. If you have Node.js on your machine, you just install it with a single line, and you can extend the stuff with any amount of native code, as I already told you. Let's have a small demo how it works. So I have Cordova already installed on my machine. As all new fancy modern frameworks, it has a command line generator of the project. So I can write Cordova, create something, and it will create a project for me. So let's go to something. And here, do you see this stuff? Or I need to make it a little bit bigger. So if you can see, there are actually, this is the structure of Cordova that it actually creates for us. So it creates the config XML file. So this config XML, it basically describes some stuff about your application, like the description, some name, but and actually it also describes where is the initial point of your app is. And the access origin, with this you can actually limit where your application can connect on the network. So you can actually write a domain here and it will be restricted to prevent some attacks or whatever. Also here you can write a lot of different configuration properties that will affect either all of the platforms or only some of them. For example, you can disable like the rubber scrolling on iPhone for your first screen or something like that. So you can do that here. Another important thing is the www. It's a directory where actually your web app is actually stored. It's a simple standard web app. So if I open it in, let's see, in a standard browser, I can just look at. So this is the default app of the Cordova. So you can see it's cool, it's responsive. You can actually make your window smaller and it will jump like this. And actually, when I develop when I test and develop my mobile apps on my computer, I do like this. So this is the screen of the mobile phone. And basically, what you see is what you get, like this. So it's pretty convenient. And you can also do the iPad sort of thing. So resize it bigger. So so it doesn't do anything very useful right now. So it's just a demo. But you can see you can store here your CSS, image, JavaScript files, whatever. And you can actually put here anything in any structure. It depends on you. So what there is else? So there is the merges directory. And merges directory was exactly the question. It is where you can actually put and redefine some of the files. For example, if you have some platform-specific CSS file, you can put it here under merges, and you can put Android / something CSS, and you put iOS something CSS. And when you build your app for Android, this file will be replaced. And when you build it for iPhone, it will be replaced with another file. So basically, it's the standard way of managing differences, platform differences, if you need them. So, and the most important thing is the platforms. So platforms directory right now is empty. And it means that my app right now doesn't support any of the platforms. So let's add one. So I do Cordova platform add Android, for example. So I have Linux. I can't do the iPhone on this computer. So what happened is that when I now list the platforms directory, I have the Android subdirectory here. So I'll now open that in actually some more serious tool. And if we look at the platforms, under Android, there is a lot of stuff. And there's the Android manifest file. Let me try to do it so that you will see. So it's the standard Android manifest that you would write if you're targeting Android. So then there's build XML, all the stuff that you would have in any Android project. So basically, the stuff here on the platforms Android is the real Android project that you can add to your idea as an Android project, and it will run. So this is basically what Cordova does for you. So when I add an iOS here, it happens the same. Here on the platforms, I get a new directory called iOS, and it has a completely valid Xcode project that I can run in Xcode and debug and test. And the good thing is that all the sources are here. You can actually change anything that you like. And let's look at the activity that it has defined here. I'm not sure if it will be. Okay, it used by default. It used the Cordova activity actually, or something like that. I will show you another project later. So now, how to run it? Now, if I want to run it or build it, I can use an IDE for that. I can use Ant for Android. I can use Xcode for iOS. But if I don't care, I can tell it Cordova build Android. And it will actually execute the Android build for me. So if I know the specifics of Android, I can go and do it myself, or Cordova actually already can do it for me. So it's quite easy and convenient to have the same interface for all the platforms. So basically what it did, it actually built, it ran the Ant for me and built the standard APK for Android. And we can also run it. It also have the command Cordova emulate Android, and it will start it will do the build again, and it will start the Android emulator for me. It will take some time. The emulators are not too fast. So let's see, waiting for emulator. So, and it's the same for iPhone basically. So if you're on a Mac, you can write Cordova emulate iOS, and it will build and run the iOS emulator. So when this Android boots up, go. Nowadays, Android emulators, they used to be very slow. Now they are a little bit faster because you can use the Intel processor in Android nowadays. So it will not emulate too much stuff. So now it runs the app. For some reason, this demo application, it looks like this on the first run. I have no idea why. Our apps are okay. So, but if I run it again, you can see it's the app. It works. So let's now go and see something cooler, like the real stuff. I hope that it will actually run. So now I can run in the emulator the same app that I showed you in my phone, but on Android emulator. So let's see. And before that, actually, while it's building and stuff, I will show you the stuff, how we actually extended the Cordova with our own code. Or maybe it runs more quickly. Go.
How long does it on average take to build a bank application?
On our server, you mean to create it or to actually build it?
Just building it.
Just build. On our build server, it's usually about 1 minute. It's actually pretty small compared to it's pretty slow compared to our other applications. Especially iPhone takes longer.
Does it include tests?
No, our tests run separately. So we actually build the content of our app. We actually don't store it in the same Cordova project. We store it in our internet banking project. We test it there, and then we actually copy the files to the Cordova project. So we have everything in one place, test it there, and then from time to time, we can execute the build for the mobile app. So let's see. Oh, it's already here. So you can see it's here. It works mostly the same. It looks very similarly. Let me see. So I can also do like this. This is the native Android menu. So I can return back. I cannot shake in the emulator. That's actually quite difficult to debug bump and shake because you can't do that without the physical device. But still not as difficult. And basically, what? Okay, so you can do the QR here. Actually, maybe I can scan it with my mobile. Yes?
Are there any integration testing tools which can simulate user behavior, for example, and which would allow you to make your...
That's what we do with our HTML stuff. We actually have the same tools that we use for testing the main internet bank. We use the same tools to test these apps. And actually, of course, we cannot test like the bump or something like that, but we can emulate that. So basically, sometimes we inject some mock JavaScript stuff while testing to simulate bump or something like that.
Maybe I want to ask almost the same question. If you develop in Google Chrome, yes, how does all those phone-specific APIs mapped, like mocked in the Chrome? Or do you mock them yourself?
We mock them ourselves.
With your camera and so on.
Yeah, so basically, when you are running under a real phone, you have together with your window object, in your code, you have the Cordova object. And if you don't have Cordova, then it means that you're in a browser and you can do something differently. If you have Cordova, then you can make decisions according to that. So I have some of these scripts here. So if we look, so for example, this thing is changing the language. It's one of the things that we actually implemented in native code. Because when I can the same problem. So when I exit and I go and, okay, to change the language, I need to reset the code. I don't want to do that. But basically, when I change the language, it's not only changing the HTML that you display. It also, the locale and the stuff, because the system messages need to be displayed also in the correct language. And that's why you cannot do that only in your JavaScript. You need to call to the native code. And that's how we do it, actually. Cordova has a point of a notion of plugins. And it has this Cordova point exec method of calling your plugins. And we have our own plugin that is called iBank app. and it has a method setLocale that we call with the parameter, and basically that's how we call the native code from our JavaScript. Of course, we have wrapped it into a nicer API, so we call actually app.setLocale, but it's under the hood is implemented like this, and the rest of the magic is done by Cordova, and it works. For example, if I now open the app plugin file, that is the implementation of our own plugin for Android. Here we can find the setLocale method, and setLocale on Android it actually does these things, so that it would work. On the plugin actually in Android, it needs to extend Cordova plugin class, and it needs to override the method execute. For some reason on Android they made it like this, so you have the name of the action that was called a string here. So if I open the same app plugin for the, I hope that it's here in the project. No, I actually have the implementation for iOS here as well. So let's find it quickly. So it's Cordova. Okay, it's file, not class. App plugin.m. So this is the Objective-C code. It's here in IDEA. It's not syntax highlighted, but it's basically the same stuff. Here we have setLocale that is implemented in Objective-C, that is called when on iPhone when we call setLocale from JavaScript, and it does something else in Objective-C. And it's the same thing. For example, if we want to show the left menu, it's the left menu, sliding menu that I showed you. Is actually I can call it using show left menu, and it will be done like this in Objective-C. And if I look at Java, then in Java it will be show left menu will be different, so it will use the Android API. So basically it's very easy for us to write any amount of native code here, and the biggest thing that we've done for these apps here is that we even have created our own main activity. Instead of using the default activity that is provided by Cordova, we actually created our own, because we wanted to have 3 activities. There's 2 menus and 1 main screen. So we actually implement Cordova interface, and we have some of our own code here that will set up the things and do some tricks for older phones and whatever. But basically I would say that we don't have much of the native code. We have like maybe 1,000 lines of code for each platforms, and we have like 99% of the code in JavaScript, which is pretty convenient. Yes?
Quick question. You were talking about updating the non-native apps on the fly through the network. So are you updating your banking application, for example, through the Play Store, or is the wrapper handling the updating of your?
Yeah, of course, we release new versions to Play Store and to App Store, and we actually don't do that on the fly, replacing of our own resources. It's just a funny possibility to think of. What we actually do is that we request some of the things from a server, and we actually can change the behavior of the app quite a bit without modifying the app itself. So app itself, it has most of the scripts, all of the images, CSS, and initial pages it has stored in it, but lots of the content is actually coming from a server. So because online banking is all about online, so it doesn't make sense to look at your account balance from yesterday. It makes sense to look at it, what is it today. So anyway, you need to access the server, and that's why we did that. So, but the first screens which asks for the PIN, then the map with the ATMs, this is all accessible offline. So, for example, ATM map is something that we actually update automatically. So we actually store them on the phone, and then sometimes when we see that we are online, we actually download the new data and then store it again, so that when the person is looking around without the internet connection, they can still see the ATMs. And it works quite nicely. So that's probably all I wanted to say. So Thank you.